Okay, here we have a piecewise function that we need to graph. The formatting got a little funky in this spot right here, so I put a bracket in there, and I also just rewrote it so that you can read it a little bit better. But f of x is negative x plus 2 if x is less than 0, and root x plus 1 if x is greater than or equal to 0. So we need to graph it over here, and then we need to answer these questions. So let's start with graphing, because I think that it's easiest to answer these three questions here with the graph in front of us. First thing I'm going to notice is this transition point at 0. So I'm going to put a little tick here. And I'm going to do some scratch work here, and then I'll highlight what the actual function is at the end. That is the transition point. We are going to follow this when x is less than 0, and this when x is greater than 0. So what I'm going to do is graph this function right here, negative x plus 2. So I'll write that here, y equals negative x plus 2. This has an m, a slope of 1, well, negative 1. So that means that it's going to go up 1 over 1, up 1 over 1 if we're going backwards, right? I guess I should say it's going to go, if these were the boxes, it would go up 1 over 1 if we go backwards, or it would go over 1 down 1 like that. So that is something with a slope of negative 1. It's also got a y-intercept of 2. So notice it's got a less than sign here. So I'm going to come up to 2, put an open circle, because that's what we do anytime it's got a less than. If it's got a less than or equal to, then we'll put a closed circle. Now, less than 0, that is on this side here. So what I need to do is I put that open circle because that's the y-intercept, and now I need to graph that slope of negative 1. So I'm just going to go backwards like this, and it's going to go like that. So that is the graph there. If I were to draw that complete, if I were to combine this and this dotted space, it would give me this full thing right here. But I don't want that full line. I only want to take that line when the x value is negative. So that's why we stick this way. So I will switch over to another color, and we'll do this piece right here. So that is root x, but it's shifted to the left by 1. So if I were to draw the whole thing, I'll just do the whole thing dotted. I would start here, and then I would go up, and I would do my 1, 1 point, and then I would go to my 4, 2 point, and then I would have a 3, 9 point way out here. So hopefully you can see this purple line right here that would be the root x plus 1, or say the root x plus 1. So notice this one has a x greater than or equal to, so we're going to take that space out there. So in order to make sure I only take that space, what I'm going to do is make a solid circle right there. Why do I do solid? Because it's greater than or equal to. And then I'm going to follow that dotted line that I drew like this. So the overall graph, I'll do it in red. It's going to have an open circle up like this. It's going to follow that part of the green, and then it's a closed circle there, and it's going to go out like that. And the dotted lines here are like the remainder pieces of those functions that aren't within these domains and ranges, or the domains that are specified right here. So hopefully you're okay with that. From there, we're going to use that to answer these questions. So domain, well, look, it's going to go back to that. Remember, domain is the axis. So it's going to keep going back this way. It's going to keep going up, which means we're going to keep have x's on this side. And then this thing continues to go off in that direction forever. So the domain is negative infinity, comma infinity. And remember, there's a couple other ways we can write that. We can write that as r for the real numbers. You can also write, I'm just going to say it out loud, not write it, but I'll write it. Negative infinity less than x less than infinity. So all of those would be options for A. Now let's go to B. Find the range. I'll do this in purple. So what I want you to see is that the lowest value we have here is 1. And then it works up through here, and it includes that spot because what I'll do is I'll go like all of these, bam, to there until we get to 1. It works there, right? Then what we can do is recognize that this line here, this also goes up to infinity, right? It goes back and it just keeps going back and up and goes up all the way to infinity. So I start at 1 and then I go up to infinity. So I'm gonna write, oops, it's not a parenthesis, and can you see why? It's a bracket with a 1 and then an infinity like that. The reason why it's a bracket is because it includes that y value of 1, and then it goes up to infinity. Remember, we always list the smaller one first and then the bigger one. Another way to write this would be would be 1 less than or equal to y less than or equal to infinity. So those would be the two answers for B. Lastly, we want to find the x and y-intercepts. So notice there is no x-intercept. This graph here doesn't hit the x-axis at all. Because remember, this is the x and this is the y. So the x-intercept would be where this thing hits the axis. And you can see that the mother function down here would hit the x-axis. And this line would hit the x-axis here, right here. But the red one, it doesn't hit anywhere. So none. And then the y-intercept, well, that one, if you look here, you may want to say 2, but look, it's open circle there. I got to take that spot where the closed circle is. So the y-intercept would be y equals 1. You could also just write 1, and that would be okay. So hopefully this helps, the coloring helps, and you're feeling moderately confident with these piecewise functions.